So we're going to talk about electronegativity. This is the tendency of an atom in a covalent bond to attract electrons toward itself. So we haven't really talked about covalent bonding yet. And this is when you have two atoms and they're sharing electrons. Okay, they form a bond by sharing electrons. So let's say, for instance, we have fluorine here and chlorine. Okay, and there's their nucleus. There's two electrons in this bond that they're sharing, and the attraction between the positive nucleus and those electrons is called a covalent bond. Okay, so fluorine has a positive nucleus and is trying to attract the electrons towards it. Okay, and chlorine has a positive nucleus and is trying to attract electrons towards itself. It's kind of like a tug of war. They're both pulling on those electrons and trying to move them closer to their positive nucleus. Unlike a tug of war, though, where the big kid always wins, in this case, the smaller atoms always win. Smaller atoms have a larger electronegativity because, let's say there's a positive nucleus and an electron. Here's a positive nucleus and an electron. This valence electron is pretty close to the nucleus. Here it's very, very far away. Because it's closer, it has a stronger attraction. Okay? Because it's farther away, it has a weaker attraction. So smaller atoms are going to have larger electronegativities. And the symbol for electronegativity is a Greek chi, but it basically just looks like an X. So you can make an X if you want to. So the group trend, remember that as you go down a group, atoms get bigger, right? Therefore, the electronegativity is going to decrease. Okay, and there's two reasons for this. As we said, as the atoms get larger, the electrons are farther from the nucleus, so they're not attracted as much. So the small atoms and then the large atoms get bigger, so electronegativity decreases. Also, the valence electrons, which are the electrons we're talking about, okay, so they're on the outside, we say that they are shielded from the nucleus. Okay, so here's a nucleus. This is called shielding. So if, say, this is in the fourth energy level right here, there's a whole third energy level of electrons here, and a second energy level, and a first energy level. So there's lots and lots of electrons between the valence electron and the nucleus. These electrons get in the way, or shield, the valence electrons from the nucleus. Because there's all these core electrons, or electrons in lower energy levels, it makes it hard for the nucleus to attract the valence electrons. Okay. You can think of it as if you have a refrigerator magnet and you try to put one piece of paper on your refrigerator, it will stick pretty well. And if you try to put two pieces of paper, it'll stick okay. But what happens if you try to put 10 or 20 pieces of paper? The magnet can't hold them anymore because all of the pieces of paper are kind of interfering with the magnet being able to attract to the refrigerator. I can show you this in class with the board. The periodic trend, pretty simple. As we go across the period, okay, we learn that atoms are getting smaller, therefore the electronegativity is going to increase. Okay, atoms are getting smaller, so electronegativity gets bigger. There is an exception, however. At the very end of each period is a noble gas. Okay, and the trend predicts that noble gases would have the highest electronegativities, but they actually have electronegativities pretty close to zero. Right? They're already really, really stable, and they have no interest in attracting electrons. So it increases, but right at the end, there's the smallest one. So there's an exception that you just have to remember. Just a quick reminder, as I go across, my atoms get smaller, so my electronegativity increases. As I go down, my atoms get bigger, so the electronegativity decreases. Look at that as a graph. This is the graph that you would have made in your graphing activity. Okay, you can see the noble gases are all way down here. Okay, so you go from hydrogen to helium as I go across. Okay, then as I go across, this is going across a period, you can see that the ionization energy is increasing, and then it drops suddenly for neon to the noble gas. And then it increases, and then it drops suddenly for the noble gas, and then it slowly increases, okay, and then drops suddenly again. So this is just a graph of what we've seen with the trends.